Hello again everyone, welcome back to ptet.chemistry channel. So in this tutorial video for the 5129 combined science, or one of those coordinated science that involve basic or elementary chemistry. In this topic we'll be covering these chemical reactions, specifically on rate of reactions, which is to do with how fast a chemical reaction normally takes place. As part of the learning objective, you as students, you should be able to describe. So the key word here is describe. So that means it's not just stating. Stating means you don't have to explain in detail, but then this is describing. So you need the details, and therefore they are the kind of thing that we will go through in this set of lecture tutorials. So first of which, there are a couple of factors that can affect how fast a reaction happens, how fast a reaction takes place. One of which is called concentration of solution. So previously in year 9 chemistry, as part of the combined science syllabus, so in year 9 you learn something under reacting masses. The very last bit of the lecture tutorials, if you go back to that topical playlist, I talk about concentration. We talk about how much of the stuff is dissolved in the distilled water to make up a solution. We talk about gram per dm cube because this is the mass of the solute. Solute is the stuff that you dissolve in a solvent, and this is per dm cube. Per dm cube per 1 dm cube of what? This is volume of the solvent. These are all part of year 9 combined science chemistry syllabus. So there is the volume of the solvent, which in most cases of solution is just distilled water. And of course, changing the surface area, so you can crush up a big piece of solid and you can crush it into very fine pieces, very fine powder. So you are increasing the surface area when you crush something big in size into much smaller, finer particles. Changing temperature, our last lecture tutorials when we talk about chemical energetics, meaning to say exothermic, endothermic, we use a lot of thermometer. So thermometer is the apparatus used to measure temperature or record temperature in the lab, and we can change temperature by changing the amount of heat or by using a cooling bath, by using ice, and we can cool solution down. Last but not least, adding or removing catalyst. So catalyst is an English word, but then in the context of chemistry, a catalyst is basically a substance that will increase the rate of reactions. Of course, when you remove the use of a catalyst, the reaction is going to be slow again. The English word comes from this verb. The verb is to catalyze, means to speed up, to increase the rate, to make things go faster. Okay, so explain that a catalyst is unchanged at the end of reaction. So you got to be able to explain that catalyst will not change its identity. We talk about chemical change and physical change at the start of the redox changes topic just a few topics ago, and of course now we learn catalyst is unchanged. So despite the what it happens is it get involved in the reaction, but you will not get change at all, not chemically at the end of the reaction. It still remains exactly as it is at the beginning. We're not going to cover in these lecture tutorials, but we'll cover in the next bit of lecture tutorials where we'll be looking at practical methods, because this is part of the new syllabus as the combined science is becoming more and more like the IGCSE combined science. There is a paper, a specific assessment called alternative to practical, where you don't actually get to do the actual practical, but without having seen how it is done, you will not be able to come up with methods to investigate rate of reaction, especially when you involve the formation of a gas. You need to collect the gas, and how do we collect the gas? That are all part of experimental techniques, and of course tests for gases will be in a topic that will come up later on as part of experimental method topic. Now this is not just stating, it's also describing, use and evaluate. These are one of the most important and one of the most difficult skill set that even pure science, pure chemistry students struggle with. So you need to really keep up with the reasoning and the thinking associated with this particular science subject. Last but not least, you got to interpret data, including graph from rate of reaction experiment. So this is basically how fast reaction is going. We need time. Time for what? Time for gas to be produced, for solid to be used up, or for concentration to change, etc., etc. Okay, so let's get started with the main content of this topic. First of all, we have effect of concentration on the rate. What is important is earlier you had candidates should be able to describe the effect on the rate by changing concentration of solutions. So here we have, if you increase the concentration of reactants, then the rate of reaction increase. That is basically what is stated in the syllabus. So this is basically saying directly proportional. This thing in the square bracket is basically concentration of reactants. I wouldn't be too worried about this thing here, so don't worry too much about that. I'll probably cross it out before these notes ever get printed. What is important is, as the concentrations of reactant is increased, reactant are the things that are used up in the reaction, then your rate of reaction will increase. Why? This is the important bit. Why? They did ask you to describe, they might ask you to explain as well. When you increase the concentration of reactants, you will increase how often they collide. Frequency means how often. When you are very close to each other, unlike COVID standard operating protocols, when you get close to each other, you're bound to bump into your friends, your neighbors, and the more you bump into each other, the greater is the rate of reaction. When you have concentration which are much higher, we know that concentration in gram per dm cube. So if you have more gram per the same dm cube, so we are saying that if we have the same volume, so let's say 1 dm cube, but then you have 5 gram in 1 dm cube, here you have 1 gram, but for the same volume, so you're going to get 5 gram per dm cube versus 1 gram per dm cube. So we say this is more concentrated. If it is more concentrated, then you have more particles. You have more particles because you have more masses, more particles in the same volume. If you have more particles in the same volume, they will collide more frequently. If they collide more frequently, frequent means often. If they collide more frequently, the rate is going to be faster. So that's why your rate increases when you have greater concentration there. Okay. Another one is this idea on metal plus acid. This is your year 9 chemistry under equations, chemical equations, as part of your home-based learning topic not too long ago actually. So I taught you metal plus acid. If you have hydrochloric acid, you're going to get a chloride. And you know magnesium is from group 2. Magnesium is in group 2. So when they form a fully filled outer shell, they lose 2 electrons and they get Mg2+. Chlorine is from group 7. When their partner is a metal, they're going to form ionic compound with ionic bond between the oppositely charged ions. This is from group 2. It loses 2 electrons and then you get a fully filled outer shell, Mg2+. Chlorine is in group 7 with 7 outer shell electrons. They gain 1 electron there in order to get to a fully filled outer shell, and therefore they have -1 charge there. Okay, so you know about the valency, meaning to say follow the number on the charges and then you crisscross or you cross multiply and exchange this number. What this means now is you just have 1 magnesium 2+ and you have 2 of that Cl-, you have MgCl2 as your formula for magnesium chloride. This is your metal salt. The salt you get from hydrochloric acid is just simply a chloride salt. This is your hydrogen gas. Again, another topic from year 9, that hydrogens just share 1 electron with another hydrogen atom, form a single covalent bond, dot and cross diagram, covalent bond between non-metal and non-metal there. So what we have here is magnesium ribbon, and then we add it to an excess of hydrochloric acid. But then if we keep both the length of magnesium and the volume of HCl constant, you simply change. What do you change? You change the different concentration of HCl. I need to tell you something about this. The length of the magnesium ribbon as well as the volume of HCl remain constant. Constant basically means not changing, because if we change those, they can affect the rate of reaction. Therefore, we don't change it. We keep it constant. Therefore, we call those control variable. In an experiment, things that can affect your results are called variables. These two things are called control variable. Why do you call them control variable? Because they can affect the rate of reaction, which is why we keep them constant. We don't change them, we just keep them constant, so we call it control variable. How about this thing that you are changing? You are changing the different concentration of HCl. So when you are changing the concentration of HCl, what you change is your x-axis. So this is on the x-axis, the horizontal level. This is now mathematics as well as physics. This is part of graph. So what you change is what you call independent variable. Independent variable is your x-axis. It is what you change in an experiment. When you change something, that is called independent variable. The time taken is found to be shorter. That is because the reaction is faster. The rate is higher. That is because reaction is faster. If your reaction takes place at a faster rate, then the rate is going to be much higher. That's because the concentration is much higher. Therefore, you get more particles in the same volume. They collide more frequently. The rate is higher. The higher the concentration, the faster is the rate of reaction. I gotta focus on this thing here now. So what is changing? What is changing? So what you change is very what you record. What you change was independent. What you record is basically the time for the reaction. The time for the reaction, this is what you record. This is going to be your y-axis. And what you have on the y-axis is what you call dependent variable. So this is what you record. What you record or what you measure is what you call dependent variable. What you change in an experiment is what you call independent variable. What you keep constant is what you call control variable. When you have a graph, you're going to have a graph of time against concentration of the HCl, because here you are just changing the concentration of the HCl, and you have the time for the reaction. As it becomes more concentrated, the time gets shorter. That was what is said there. As it becomes more concentrated, the time gets shorter because the rate is faster. Here it means shorter time for the reactions. Therefore, more concentrated, shorter time. This thing on the x-axis, this is what you call x-axis. This thing is what you call y-axis there. X-axis is your horizontal axis. Y-axis is your vertical axis. The x-axis is what you call independent variable. Independent variable is what you change. And then on the y-axis is what you measure. That is called dependent variable. My friend once taught me the easy way to remember it is, why are you so dependent? Why are you so dependent? I say it again, all right? Why are you so dependent? Okay, so y-axis is the dependent variable, is what you measure as you change the x-axis, which is your independent variable. I'll leave it here for this lecture tutorial, and I'll continue more on the other factors that will affect rate of reactions. But just remember that when you have more concentrated solutions, you have more particles in the same volume, so they collide more frequently. Rate of reaction is going to be faster with the more concentrated solution there. Okay, I'll see you in the next lecture tutorial. So thank you for watching. Don't forget to click the button on the bottom right to subscribe to my channel. Follow me at ptet.chemistry. That's at ptet.chemistry on Facebook, Instagram, Twitter, and Telegram to get connected.